Right, so tonight I'm going to take a look at page 412, and I'm going to take a look at question 3, and I'm going to do part 2. So you should have had that homework done for last night. And I'm going to look at a new question, let's say maybe question 6, and then I will leave you guys with question 4, 5, and maybe 7 as well, okay? Oh, and that's with the new book, the old book, or sorry, that's the old book, the new book. If you're in 5th year looking at this, you will have a different page number, but I'll put all that up on Teams for you. Now, so I suppose let's just jump straight into it. So we have this side over here, which is 7. So this is question 3, part 2, by the way. Okay, so I'm obviously not using my Surface Pro today because my charger is in school. So hopefully I won't run out of paper. I think this arrow down here is the limit of my as deep as I can go. So I'll try and get it in one page because it'd be a nightmare for you guys. I'd be looking at 2 different pages. So that's going to be B, that's going to be 10. So I think it might be actually better doing it this way because I can point to things and I can draw on things a lot easier, okay? So when we have this situation with an angle trapped in between 2 sides, and we have some information about the side opposite it, well then that's kind of a setup for the cosine rule, okay? So we're going to use the cosine rule, which tells us that a squared is equal to b squared plus c squared minus 2bc cosine of a. So I now need to label up my diagram. I think I've been using green pen on the Surface Pro, so I'll try and get a green pen. I have one here. So I'm going to call the angle the big A, and then therefore the 7 over here, we call that the small a. And then that's going to be our B and that's going to be our C. It doesn't matter which is B and which is C. So I can then set it up. A squared is equal to something squared plus something squared minus 2 something something cos something. And into A I put in 7. Into B I put in 9. Into C I put in 10. Into B I put in 9. Into C I put in 10. And into A I put in B. So I know that's really weird that we would change from the letter A to the letter B, but that's just the way it is. In order for us to use this formula as it's set out there, that's kind of the thing we have to do. So try not to confuse yourself with that. It's not that big a deal. Okay. Now, well, I can start putting stuff in my calculator. That gives me 49. That gives me 81. That gives me 100. That gives me 180 cos of B. So I can now just do it like a normal algebraic sum. 49 is equal to 181 minus 180 cos B. So minus 180 cos or cosine B is equal to 49 minus 181. 49 minus 181 equals minus 132 is equal to minus 180 cos of B. So I'm going to have to scroll up here just to be safe. Yeah, that's probably the handiest thing to do is to scroll up. Okay, now I want cos B by itself, which means I'm going to divide by this 180. So minus 132 divided by minus 180. So cos of B is equal to 0.73 recurring. So therefore B by itself is equal to cosine inverse of 0.733 whatever. So if I do shift cos and then I hit answer on my calculator, actually I might as well start doing the calculator since you can see it. I'll do it in the next time, it's too late now. Equals, so B is equal to 42.83 and that's going to be measured in degrees. We asked for nearest degree or anything? The nearest degree, so that's going to be Sorry, these pens are not designed for left-handed people. 43 degrees is equal to B. So that's the size of the angle B, 43 degrees to the nearest degree. So I suppose we set this up. We know we're dealing with this, either the sine rule or the cosine rule, because we've got a non-right angle triangle here. It's just any old triangle. When we have that situation, we cannot just use straightforward sine, cos, and tan. We're going to have to use our sine rule or our cosine rule. And our cosine rule, well, that tells us that we have to have an angle trapped in between two known sides, and we're dealing with the side opposite that angle. The sine rule, it's all to do with opposites, okay? It's A over sine A and B over sine B. Remember that? So it's to do with opposites for the sine rule. But for the cosine rule, it's this notion of trapping it in between two known sides. So that was question 3, part 2. I'll jump on now to question 6. See how we get on with that. So I think I can go again, just put an arrow on my page where I can go to. I think about there. Right. So the distance from the tree to the pin on the green is 190 meters. Okay. From the T, not the tree. I was thinking from the T to the pin on the green is 190 meters. A golfer hits the shot at an angle of 20 degrees away from the direct line to the hole. If the ball travels 170 meters in this distance, find the distance between the ball and the hole. Oh yeah, okay. So I'm not really interested in golfing or anything like that. All I'm interested in is triangle, so I'm going to draw my triangle. And what I have here is 170, that's the ball. And that's T, and that's 190. And I want to know this distance here. So I'm going to call that the distance x. We know that angle in there is 20 degrees. So we have to work out the length of that angle x. Now, the way I've drawn it here, it looks like it could be a right angle. But I don't assume that. I would never just assume it's a right angle. Not unless I'm actually told it is a right angle. So let's look at what we have. Well, we seem to have an angle here trapped in between two kind of known sides, and we're looking for something opposite the angle. So that's telling me we're going to use the cosine rule. So we have to use a squared is equal to b squared plus c squared minus 2bc cos of a. Now, we need to label up our diagram. So the big angle here corresponds to that big A there, and then that makes that x the small a, and then that makes that the b, and that makes that the c. So let's put it into my formula. Squared is equal to something squared plus something squared minus 2 times something something cos of something. Right, into this one here I'm going to put in x. Into this one here I'm going to put in 170, 190, 170, 190, and I'm going to call him 20. Okay, now I can put the entire right-hand side into my calculator in one fell swoop. So that will give me x. X squared is equal to, I wonder is there some sort of a, maybe it's not just left-handed people who have a problem with these pens. The problem is that, I don't know if you can see it or not, the problem is that there are, to put the nib back in, you press this thing here, and that releases the mechanism, okay? But the way I hold the pen, maybe it's because I'm left-handed, I have a tendency to touch off this by accident. So yeah, maybe right-handed people have the same problem. Now, so let's do it on the calculator. Let's see how I would tackle that. Can we do them side by side? I have a big post over here on the right that you probably can't see. Am I recording here at all? I am. Okay, we've gone 9 minutes 30. Right. So start bracket 170 squared plus start bracket 190 squared minus 2 times start bracket 170 close bracket start bracket 190 close bracket, and then cos of 20 equals So x squared is equal to 4295.86 meters. Can I say meters there? I better not. I'm not sure what those units would be. It's probably actually meters squared, but anyway, it's not important. So x by itself will equal the square root of answer. Really powerful tool there. So I'll just get out of that again. So that's what we had in our calculator. Now, I don't have to key in square root of that number. I can just hit A and S, and that gives me 65.54 meters. So the golf ball is 65.54 meters from the hole. Yeah, okay, job done. So can you guys have a go at question 4, question 5, and question 7 for homework? My plan for the lesson, the next lesson that I have you for, which probably won't be until after the midterm, will be that we will organize a scheme. So when you come across a trigonometry question, you'll know which strategy you have to use. And once we have that scheme learned, we can then start doing the miscellaneous questions at the back, the test yourself questions, okay? So we're pretty much finished. We're as far as I want to go with the cosine. Sorry, we're as far as I want to go really with trigonometry. There's very little new theory to learn. Maybe just how the overall scheme of trigonometry fits in together, and then that's trigonometry done. So we're coming towards the end, guys. So I'll see you in the next lesson.